Here we go. Solving polynomial equations. Now, in this particular case, we are going to solve polynomial equations by factoring. So looking here, and I did the three types. There's type 1, which is difference of squares. So notice, you would notice that m times m is n squared. 5 times 5 is 25. They have the subtraction sign in the middle, so it's a difference of squares. And that gives us m plus 5. M minus 5 is 0. So now we set, due to the zero factor theorem, each piece equal to 0. And at some point we're going to graph these, and you're going to see the kind of information it yields about the graph of the equation. And you're going to get m plus 5 is 0. You're going to subtract 5 from both sides, and m is negative 5. And then here, m minus 5, we're going to add 5 to both sides, and m equals 5. So in this case, there are two solutions. Later you're going to find out that's where the graph, if we were to graph this, crosses the x-axis, or in this case the m-axis. Okay, this is trinomial. Oops. Now this is nothing but it's suspicious. A 5, now notice x squared and a minus. First we have to factor what it's in common. So these both have a 5 in common. And 5 times x squared is 5x squared. And 5 times negative 4 is negative 20. And notice we have yet another factorization we can perform. So we have 5, x plus 2, x minus 2 is 0. Zero factor theorem, we're going to set each piece equal to 0. And we're going to solve. And here, this is an untrue statement. So this, the answer is not no solution. This doesn't give us any meaningful information. It will later in advanced math classes. But for this moment, for our purposes, this doesn't give us information that's relevant in this situation. And now for this one, you're going to subtract 2 from each side. And here you're going to add 2 to each side. So notice here again, we have two solutions. Looking here, it's the previous factor lesson, factoring trinomial. And so in this case, we're going to look at all the factors of 32. So we have 15 times 2, we have 32, we have 8 times 4. And notice adding and subtracting a 15 and a 2. Do not add or subtract to our middle term, a negative 12. 32 and a 1. Do not add or subtract to give us the middle term, a negative 12. Notice though, a negative 8 and a negative 4 give us negative 12. So we're going to set each piece equal to 0. And we have two solutions, 8 and 4. Going to the next one, again, common trinomial factoring pattern. And we're going to do 6 times 8. Now I could keep going, but notice a 6 and an 8 make a positive 2. So that's going to be a positive 8 and a negative 6, if we were to FOIL, would give us that middle term, a 2x. And as we've been doing, we set each piece equal to 0. And we're going to solve. So now we have x is negative 8 and x is 6. Two solutions. Okay, so 4 terms. Oops, you can't see. Let me move it. 4 terms is factored by grouping. So notice here, you look at the first 2 terms, and we can pull out a 5. And notice if we were to distribute that, we get 5 times x is 5x. 5 times 6 is 30. Looking at the next 2 terms, can factor out an x, and that gives me an x plus 6. Now you take the two that are all alone. Oops, sorry. Had a momentary freezing moment there. That matches, so you did it right. And that equals 0. And hopefully now you can see the pattern, what you're supposed to do. I'm making more room for us. You're setting each piece equal to 0 now that it's factored. So you're going to take x plus 6, and you're going to take and there are two solutions, -5 and -6. Last example, looking at the first two, you can pull out a 4. There's have a 4 in common, and we get x squared minus 9. And now we're going to look at the next two, and they have an x in common. So you're going to pull out an x, and that's also going to leave you with x squared minus 9. Notice, factor by grouping, if the two parentheses match, then you know you did it right. So now you're going to slap the two that are alone together. Now notice, since we're doing this by factoring, we're still not done. Because x squared minus 9 is a difference of squares. So x plus 3, x minus 3. I'm going to pull this up here because it's difficult to see. So I'm going to just recopy this. So we have, once we factored it, we got x plus 4, x plus 3, x minus 3. And we set each piece equal to 0. Because we are solving, which means we're isolating x. And now we're going to solve. And we're going to isolate the x by subtracting 4 from both sides. Subtract 3, isolating the x from both sides. And then here, to get the x isolated, we add 3 to both sides, and we get 3. Now notice in this case, there are 3 solutions. And that is solving polynomial functions.